the graph of the function f is shown. Which of the following statements must be true or must be false? So we're trying to figure out which one's false. Limit as x approaches 2 from the left. As I go to 2 to the left, am I getting, oh, sorry, that's the right. 2 from the left, am I getting closer and closer to 3? Yep. Limit as x approaches 2 from the right, I'm getting closer and closer to infinity. The limit as x approaches 2 is equal to the value. If it were equal to the value, what would be happening at 2? It's continuous. Is it continuous? No, you got to pick up your pencil. So C is the correct answer, because as I head this way, I'm going to get closer and closer to 0, which is true. So when it's not true, it's not continuous. Next one. What is a reasonable estimate for the limit as x approaches -3 with a plus sign? Look at that. Hold it up. They are trying to trick you into DNE, but we're finding the limit as x approaches 3 from the right side. So if it's from the right side, do I care about what's happening over here? No. All I care about is 3 from the right side, or in other words, this way. That's coming from the right side. Number's bigger than 3. And so my answer is, what am I getting closer to? Closer and closer to 1. Next one. Find the limit as x approaches positive and negative infinity. The limit as x approaches plus or minus infinity. As I go to the right, what am I getting closer and closer to? 0. As I head to the left, what am I getting closer and closer to? 1. And so it's just, where is this going? Where is this going? It's 0 and 1. Take a second. Tell your neighbor, what question could I have asked that would have given you the exact same answer that you just told me? And by the same answers, I mean are asking the exact same question as well. What is the same exact question as saying, what is the limit as x approaches plus or minus infinity? Horizontal asymptotes. Those are the same thing. Limits as we approach positive infinity and negative infinity are the same thing as horizontal asymptotes. Can you have more than one horizontal asymptote? Yeah. Next one. Got a couple graphs here. Find the limits. Limit as x approaches 0. As I get closer and closer to 0, I'm getting closer and closer to 3. 2 from the left. So as I get closer to 2 from the left side, I'm getting closer to still 3. Limit as x approaches -1 from the right, I'm getting closer and closer to 0. And then the only one we really struggled with was the limit as x approaches -4 from not a side, but can you have one-sided limits? If it's an ending value here, we can have a one-sided limit. I'm getting closer and closer to 2. It's a weird question. I can understand why you picked D and E here, but as I'm approaching it from one side, I'm going to be 2. Is it continuous there? No, not continuous.
If it said the limit as x approaches -4 from the left, would that be?
Yeah, that would be D and E, because I can't find the limit from the left. But since it hasn't specified here, I'm going to assume that it's a one-sided limit, and we can have one-sided limits. That's okay.
So since it's at the end, you can do that?
You can have a limit on an end, yep. I don't see them asking a question like that, but there it is. This one's a little bit tougher. This is more properties of exponents than anything else. Find the limit, natural log of x cubed, x natural log of 3. Find the limit as x approaches 3. The correct answer to this question is C. In order to decide if they're continuous or not, it's not going to be continuous at 0 because you can't take the natural log of 0. But in order for us to find what the limit is as x approaches 3, I want to plug in 3. And so if I plugged in 3 into that top one, I'd get the natural log of 3 cubed. And I'm trying to see, is that equal to 3 natural log of 3? Are those two things equal to each other? That's properties of exponents and understanding those concepts. Remember, if you have this right here, you can take a 3 out in front, or vice versa. That 3 could become the exponent. It is the same thing as natural log of 27. Just properties of exponents. They don't really mean a whole, or of logarithms. My other students right now in Chapter 5, when we get into that point, which will be next year for you guys, you need to know your properties of logarithms. So there it is. Next one. Find the limit as x approaches 0. We stumbled here a little bit with the top. As I look at this thing, when you plug in 0 initially, what do you get? 0, 0. And so as I look at this, I could factor, cancel, plug back in. I've got to get rid of the x's. That's the key to this. They're not just regular factor problems, so I'm not going to be able to cancel out perfectly. What do you notice about every single part in this problem? They all have an x, and so some of you tried to rewrite this as pretty little stuff inside of parentheses. I'm just going to take an x out of everything. So now it's 2x cubed plus x to the first power over 3x squared minus 4. I canceled an x out of everything. Can I continue to cancel out an x out of everything? No. And so I'm kind of there. I had to cancel. I canceled out an x. Now when I plug in 0 on top and bottom, am I getting 0 on top and bottom? No. On top I'm going to get 0, but what am I going to get on bottom? -4. My answer is 0. All right, so just looking at that, I think part of the things you guys struggled with is you took out a 2x on top and you left with this 2x plus 1. But remember, you're multiplying that by 0, and so it's going to go away. The answer was B. Find h of g of x. It is h times g of x. We are finding the limit as x approaches 3. Initially, when you look at it at 3 for both of these graphs, it looks like they're both D and E, and so that's going to tell me, hang on, let's find it from both sides. And so then I'm going to find the limit as x approaches 3 from the left. And so if I approach 3 from the left, I'm going to find my h value times my g value. H from the left is getting closer and closer to 1, where g from the left is getting closer and closer to 5. And so we followed this path. Here, that's 1, that's 5. It's 1 times 5, that gets me 5. Once I find that, then I'm going to find the limit as x approaches 3 from the right. 3 from the right, I'm getting closer and closer to 5 on that one, and 1 on that one, so 5 times 1. That also gets me 5. If both limits are equal to each other, then the limit exists. The limit is 5. Number 11, our next one. Which of the following functions are continuous for all real numbers x? This really could just be a pre-calc question. Look at it, see what you think. And so to do this problem, let's think about what each picture looks like. You're pretty confident in 2 of these. The one you don't know is x to the 2/3 power. Think about this. What number could I plug into x to the 2/3 power that would get you undefined or doesn't exist? You're cube rooting. Can you cube root numbers? You can cube root any number, and then you're going to square it. And so there's no x value that you could plug in and this not work. The graph looks like this. Okay? There's no number. If I plug in 0, I can take the cube root of 0. If I plug in -10 billion, I can take the cube root of that and then square it. It's going to be okay. And so A is continuous. Show me with your arms, what does e to the x look like? It's an exponential graph. So an exponential graph looks like this. Did I have to pick up my pencil to graph that? It goes both ways. It's continuous for all real numbers. So those 2 are good. Tangent graphs. Why aren't tangent graphs continuous? It's segmented. Remember, oh my gosh, that's not a tangent graph. That's a tangent graph, and then you'd have another one, and then another one. You have asymptotes there.
Would a square root graph be continuous?
A square root graph is not continuous for all real numbers. It would be continuous from the starting point to the right, but not for all real numbers. And that was the key here. Other questions there? Next one. It's basically the domain. Domain and continuous are the same question. Let g be a continuous function on the closed interval from -1 to 5. A few values of g are given in that table. Which interval must contain a solution of 3? The answer is A, because IVT. We could graph that really quickly. 3 falls between 0 and 4, so we can see that, and you can obviously see from the lines that in order to hit y equals 3, it's between these 2 dots that's going to happen. Next one. Suppose that f is continuous function defined for all real numbers x, and f of -5 is 3, and f of -1 is -2. If f of c equals 0, for one and only one value of c, which of the following could be c? That's a calculus question. It looks funky. When in doubt, graph it out. See what you can do. Question between -5, 3, so that's this ordered pair right here, and -1, -2, that's this ordered pair. F of c, where c is an x value, is going to be equal to 0. What could be the possible value for c? Well, I have to hit it in between those 2 numbers. And so the x value needs to be between -5 and -1. Which one of those numbers is between -5 and -1? B, -2. Next one. Which limit expression agrees with the graph? So I'm giving you 3 choices there. You can choose all answers that apply. Here we go. Limit as x approaches 0 from the right. As I approach 0 from the right, what am I getting closer and closer to? Positive infinity. It says negative infinity, so it's not A. As we approach 0 from both sides. It's a weird question, but I am getting closer to infinity. We would say it's D and E. The AP exam will either say D and E or infinity. You can be good with either one. Limit as x approaches 4 from the right. This is 4. This is the right-hand side. I'm getting closer to negative infinity, so my 2 answers are B and C. The graph of the function f is shown. Which of the following statements about f is false? Select all that apply. The answers here, is x in the domain? No, because there's no value. And so A is false because there is no value. If there was a closed circle right here, then it's in the domain, but there's not, so it's not. The limit as x approaches 1 and x approaches 1 from the right and the left. Oh yeah, those are equal to each other, which is the same question as D. The limit exists. And so B and D are true. That makes them not an answer to our question of which is false. Is it continuous at 1? No, because there's an open circle. A and C are the answers. Last problem. Last one. Do one more and we'll be done. Try this one. Here we go. Let's look at it. Removable discontinuity. A removable discontinuity. In other words, what is happening if there's a removable discontinuity? There's a hole. Removable discontinuity is a hole. All right, so let's look at this. This thing is x minus 3 discontinuous. Is it a continuous function? Yes. Is this a continuous function? Yes. Is this a continuous function? No. Where is it not where's that last function not continuous? At 3. But if it were 3, would you plug into this equation? No, because I only want to plug in x is greater than 6. And so my only options for where you would have a removable discontinuity is at 2 and at 6. Those are the 2 spots that are true here, okay? Because those 2 things could be true. Can you have a removable discontinuity there? Yes, because neither of them are equal to. It's not greater than or equal to. Both of them are just right up until 2. There's 2 things that could then happen. In order to be removable discontinuity, a hole, you could have this happen. Is that a hole? No. What is that? That's a jump. That is not a removable discontinuity. Is this a hole? Yes. So what needs to be true about these 2 equations at 2 for it to be a removable discontinuity? They have a limit. They need to be equal to the same value. And so we would check that real quick. And so we would find the limit as x approaches 2 from the left and the limit as x approaches 2 from the right. And so it'd be 2 minus 3 and -2 squared plus 3. This is -4 plus 3. This is -1. This is -1. Those 2 things are equal. The limit exists. The value does not exist, which makes it a removable discontinuity. So the answer is B. If I did that to the other one, what do you get when you plug in 6 to that thing? -33, and what's the other side? 33? 36. That's 12. Are those 2 things equal to each other? That's a jump discontinuity at 6. A different question, but a good question. It makes you think a little bit more. No, because